homework 1.2, which is dimensional analysis practice. So first one starts out with an easy one. One you can do certainly without dimensional analysis. A lot of these you can. I strongly encourage you to practice the dimensional analysis part of this. These are set up to practice that specifically because it's a very useful tool. And you may find that if you use dimensional analysis, you're more likely to get the correct answer. It's easy to make mistakes, especially on some of these that are really, really long. Number one just says, if your mother makes you an apple pie for every 3 times you clean your bedroom, you cleaned out your bedroom 9 times, how many apple pies does she owe you? We've got a conversion here. Actually, two that are linked. So, and that's 1 pie for every 3 times that you clean your bedroom. That's an equivalent. So 1 pie equals 3 cleanings, and we can associate those together. We could either write 1 pie over 3 cleanings or 3 cleanings over 1 pie, and they mean the same thing, top to bottom. We also have that we cleaned our bedroom 9 times, and that doesn't have a conversion directly. Because of that, I want to start with that 9 cleanings. Whenever possible, I start with something that's kind of on its own, that's only a single unit rather than 2 units that are tied together. So we got our 9 cleanings. Going to multiply that by our conversion factor of 1 pie per 3 cleanings. The cleanings here cancels with the cleanings there, and I get only pies left. 9 divided by 3 is 3 pies. To say that she actually owes you that, though, is a little presumptuous, I think. Number 2, I won't read completely. It's a long description, but I go down to saying that I want to gain acceptance to 10 colleges. And that, again, I've got all these other ones kind of spelled out as hints. All those are equivalences. 10 colleges doesn't have that equivalence, so I'm going to start with it. Start with the 10 acceptances to college, put a 1 just as a placeholder. Now I'm going to start working and trying to remove my units. So whatever equivalence fraction or ratio I use next should have acceptances in the bottom so I can cross those out. I know that eventually I need to figure out how many cleanings I need. So that's what I'd like to end up with. So I'll keep working until that's the only units I have. Looking up above, I know that there are 3 applications for every acceptance, so I'll use that. Then I want to get rid of applications. See that for every application, I need to write 3 essays. I also see that for each essay, I need to spend 2 hours on it. And every hour I spend writing an essay, being very tough mental work, which we know burns calories, it's 125 calories just sitting there thinking. If I'm going to gain those calories, I need to eat pies, and there's 1,000 calories every pie. And from above, I know that I need to clean my room 3 times for every pie. Going through here, I've crossed out all of the units except cleanings. And in order to figure out the total, I'll just go through and in a single step in my calculator, I'll just say 10 times 3 times 3 times 2 times 125 since they're all on top. Then divide by 1,000 because that's on the bottom. Multiply by 3, and I get 67.5 cleanings. Since we've got a couple measured values in here, I mean, this is counted. I know that I need 3 applications for every acceptance. I know that I need, that one you could argue is measured. But 3 essays per application. But now 2 hours for essay, that's more of a measured value, as is 125 calories burned every hour, 1 pie per 1,000 calories, another measured one. Here's a counted one, 3 cleanings per pie. Remember, whenever we have counted numbers or conversions within the same system, so within the metric system, centimeters to meters, for example, those are infinite precision, so we don't have to worry about them as far as significant digits go. But anytime we have a measured number like this, we do have to worry about it. Since it says 2 hours without any decimal places, that's a single significant digit. I can only have one in my answer. So this would round to 70 cleanings. Technically speaking, since I get a pi for every 3 cleanings, it would be 69. Number 3, how many minutes in a leap year? This one, there's some, you can do some debating about. I'm going to assume that all of these are exact numbers, even though technically they're not. But in one leap year, I'm going to start out with that because that's the only place I can start. There are 366 days. I know that there are 24 hours per day. Now, I'm taking this as an exact number, despite the fact that there really aren't exactly 24 hours. It's just slightly off. But I think we're good enough. This is dimensional analysis practice first and foremost. And there are exactly 60 minutes in every hour, so that one's good there. Totals up to 527,040 minutes. If I assume all these are counted numbers, then I have infinite precision, and I just record the total. 4. Given that the radius of the Earth is 6.4 times 10 to the 6 meters, took you 4 weeks to walk around the equator nonstop. How far? 4.0 weeks. How far would you average every day? So we're looking for a distance in kilometers per day as our end results. When I'm actually given 2 things. I'm given a distance, which if I multiply by 2 pi, that radius by 2 pi, I get the circumference of the Earth, so that's how far I'm walking. I also get a time in weeks. I know through experience that if I want to end up in kilometers per day, that means I need to start in a distance over a time. So I would not want to start with 4 weeks up here because I'd have to end up flipping it to get days on the bottom. And I just know that through experience. So I want to start out with a distance. Every circuit or every circumnavigation of the Earth is this distance, 2 pi times the radius. I also know that every circuit is going to take me 4 weeks. So that lets me cross out circuits. Now I'm going to convert the distance because I start in meters, I want to get into kilometers. I know that every kilometer is 1,000 meters. Takes care of that. I'm in kilometers like I want. And then I want to switch from weeks to days. Weeks are on the bottom, so I get 1 week on top. It's equal to 7 days. This is a counted number. This is an exact definition, so infinite precision there. But we only have 2 significant digits here. 2 on the 6.4. So this works out to 1,436 because I take this number divided by 4, divided by 1,000, divided by 7. But I can only have 2 significant digits, so I have to round back to 1,400 kilometers per day. Number 5, I built my rocket ship. Here's my cat Pippin. He's gained a fair bit of weight since here. He's a little overweight, so missing a few meals would not be a big deal, although the number that this turns out to, he would be extremely unhappy. And if I also neglected to give him water, he might really have problems, since also typically in spacecraft the air is fairly dry. But that notwithstanding, let's just figure out if I were to send him on that rocket ship, how many feedings he'd miss. I am at least going to time this at perigee, which is when the moon is closest to the Earth. And it's at a distance of 3.57 times 10 to the 5th kilometers. That's 3 significant digits there. I have to basically double that. There'd be some distance around the moon too, but basically double that to get there and back. So that's my distance that I'm starting with. I'm going to, since I know a speed in meters per second, I'm going to have to convert this kilometers into meters in order to be able to use that and cross stuff out. So I know there are 1,000 meters per kilometer. Here I'm going to use a little trick. Because this 1.03 times 10 to the 3 meters per second could be written two ways. It could be written this number of meters over 1 second, or 1 second over this number of meters, which is what I need to do here, so I can cross out the meters with other meters, because I want to get to feedings, which has nothing to do with meters. So I need to get rid of distance entirely. Remember that this 1 second is assumed to have the same number of significant digits as the 1.03 down here. So now I've got seconds left if I'm following this along. I want to figure out basically in days, because I know that there are 2 feedings per day. So seconds to minutes, 1 minute is equal to 60 seconds. Then to hours, 1 hour is 60 minutes, and I'm crossing these units out as I go. I know each day is 24 hours, and I know that there are 2 feedings per day. Now this is counted number, so that's exact. This is exact definition, definition here and here, so all those are exact. The only ones with significant digits that we need to worry about are the speed, which has 3, and the distance, which has 3. So my answer can have 3. I come up with 16.04. I'd round that to 16.0, and since they are a counted number, 16 is really just as precise. So he would be missing out. Considering he's the one that wakes us up early because he's hungry, I wouldn't want to be on the ship with him. On to number 6. A physics teacher played golf during the summer, discovered a liquid that, when consumed, caused him to slice ball after ball into the water without a care in the world. I have no recollection of this. Well, carrying on. The liquid had a mass, took a bunch of it, had a mass of 455 golf balls, and the volume of that was 620 water cups. From the 7th hole, gives the mass of a golf ball as 50 grams, and those cups as 45.0 milliliters. So if I'm counting significant digits, this is a counted number, 620, so it's exact. 455 golf balls, that's exact. You could argue either way that these are not exact, but I think for our purposes we're fine. Here is a measurement of 3 significant digits and another measurement of 3 significant digits. I'm going to take that to mean that our answer should have 3 significant digits. I'm going to start out with first piece of information here. We could do it in other ways. This one could be ordered in practically anyway, and you'll get a good answer. I'm going to start out with the 455 golf balls that have a volume of 620 water cups. You could split this out or keep it together however you wish. The important thing is that the golf balls will be on top and the water cups will be on bottom, because I know that I want grams per milliliter in my answer. So that means I need to switch from golf balls into the mass of golf balls, and there are 50.0 grams every golf ball. Takes care of that. And then I want to get rid of the unit of water cups and put that into the volume of water cups, which is milliliters. I know that every cup is 45.0 milliliters. Multiplying and dividing this out, I get 0.08154 grams per milliliter. That would be rounded either to 0.0815 grams per milliliter if you assume that both of these numbers are counted, or 0.82 grams per milliliter if you assume that these are measured, in which case the 620 water cups would be 2 significant digits.